the copy constructor and this copy assignment operator equals to are not always used. So sometimes you don't really have to sort of do this kind of copy construction or do copy assignment for every object. This is especially true if your object contains a very large data member. For this example class, you have just some very small containers, a string, a int, a string, and a vector floats. And this vector floats actually has just 3 elements in it, because your initialization is always like 3 elements in it. So the data stored in a object, the person object, is actually quite small. So making a copy of those very small data objects is not so costly. It's actually quite cheap, and it's not a problem to make a copy of those things. But suppose you have a vector that has like more than 10 million numbers in it, and it's going to be really expensive both in terms of speed and also in terms of the memory usage to really make a copy of that huge data object. And in that case, you probably want to avoid using copy constructor, or you may want to avoid doing the kind of copy assignment. And if you do not write your own copy constructor, if you do not write your own copy assignment, the system is going to try to generate a copy constructor or copy assignment for you if you actually are actually using the kind of assignment operator or using the copy constructor. So of course, if you don't really want to do the copy, you should not try to sort of do this kind of a copy construction or copy assignment. You should not try to do that, right? But sometimes people do that by mistake, and especially if the user of the class doesn't exactly understand how large the data object could be. So people may do this kind of thing by mistake if you have a very large data member, right? And the system is going to allow the user to do that because it's going to generate the default copy constructors or copy assignments for the class. And if you want to prevent the system from doing that, if you want to prevent the system from generating those default copy constructors, default copy assignment operators, what you can do is to you write your own copy constructor. You write your own copy constructor. You write your own copy assignment, but you make those functions private. So here it's sort of inside of the public section, right? So if you actually make it private, just like that, and then you define for example, a copy constructor. Reference P, and then you don't really need to write any stuff into the body of the function. You just keep it as some kind of placeholder, but it's inside of the private section. And then you comment out this public copy constructor. Now the system is not going to generate a copy constructor for you because you already have a copy constructor. But the user cannot really call the copy constructor by themselves because the copy constructor is private, so you cannot call that. So you can sort of save it. Let's see if it's going to bypass the. So now you're getting a compilation error, and the error was generated here. So it's not allowing you. The compiler is not really allowing you to do that. So if you actually comment out these two lines, you have to comment out these lines also because it's not because you are not sort of defining the. So now the compiler recognizes the codes. So this way you can prevent the user from using the copy constructor incorrectly, and you will also prevent the system to generate the default copy constructor. The same thing also applies to the copy assignment. You can also make your copy assignment also private, so that you can sort of prevent the user from using the copy assignment incorrectly. right? And also prevent the system to generate the default copy assignment operator. Now let's talk about how to access those private data members. And there's the terminology in C++ language is called accessors and mutators. Accessors is basically a way for retrieving the value inside those private data members. And mutators are basically functions that allows you to change the value of those private data members. So because the data members are now private, so the user of your class cannot directly access those data members. So suppose I want to sort of do change the p.age equals to, if I want to do a plus plus, just increase the age by 1. The compiler is not going to allow me to do that because I'm accessing a private data member. So if I save it and compile it, it's going to tell me that the age is private, so I cannot do that. So, but we still need some way to actually access those data members, and this is where we need to discuss accessors and mutators. So those accessors and mutators are public member functions, of the class. The data are still private, but you can make public member functions that allows the user to access those private data members. So suppose we would like to sort of allow the user to access the age, for example. We would like to allow the user to read the age and also change the age of the data member, the private data member. So how are we going to do that? So suppose we want to write a function that's going to return the age of the user. What we can do is to do age, and then just return age. Sorry, I forgot the brackets are wrong. So again, this access function is defining in an inline way, so it's an inline function, and this function takes no input, and then it's going to return an integer, and it's going to return the age of this of the object. So if you do that, and then if you actually try to sort of p.age, maybe I'm going to do a cout p.age, it should work. Let me just exit 1 to reduce the printout from the rest of the codes. If I just compile it and then run it, it's gonna so p.print is still gonna print out the complete information, and then p.age with the capital A is gonna print out 30. So this line is gonna print out the age. It's gonna be 30, and you have to sort of pay attention to the name of the function. You cannot define a function that has exactly the same name as your private data member. So if you actually change it to age, it's not going to work. The compiler is going to complain. It's a wrong function. It's a wrong function name. It's going to give you lots of errors. So you cannot really define a function using the same name as your data member. You cannot do that. So let me still change it back to big A. So now if you run it, it's gonna be correct, right? So that's basically just returning the age of the object of the person object. Now suppose you would like to modify the age. You would like to change the age. So we can define another function, and this function is gonna return nothing, return a void. And I'm going to overload the function. So I'm still going to use the same function name that's called big A, capital AGE. Now it's going to take an input. And this input is another int. Let's just call it AG. And inside the body of the function, I'm going to assign AG to just AG. And then that's pretty much it. If I want to change the age, for example, if I want to change the age. Suppose I want to do p.age, but now I'm gonna change it to like 40. And then if I still do cout p.age, and you'll see that age has been changed to 40. Let's just compile it. I have a syntax error because I accidentally put the semicolon outside of the curly brackets. Let's give it a run. So at the beginning it was 30, the age was 30, and then after this, after I change the age to 40, it's gonna print out at 40. So now suppose if you want to sort of increase the age by say 1, how you can do that, right? How you can do that? You can do that by calling the age. So you can do that by calling the modifier, the mutator. This is a call to mutator because I'm gonna give it an input. The accessor doesn't have an input because the accessor doesn't have an input. But I'm gonna call the mutator. I'm gonna give it an input. I'm gonna give it some number. I'm gonna say x. But what's gonna be the number x? What's gonna be the number x? I want the number x to be the current age plus 1. The current age. How do I get access to the current age? I use the accessor without the input. So here I'm actually calling the accessor because this one doesn't have an input. This call doesn't have an input, so it's an accessor. And then I'm gonna add 1 to the current age. And then I'm gonna use this thing as the input to the mutator. So now let's see what's gonna be the current age, right? This time it's gonna be 41. So it's 30, 40, 41. So you sort of see the kind of how we can actually use the accessor and the mutator to make changes and also to access the private data members. For now, it's the accessor just returns. For now, the accessor just returns the age, right? And the mutator just sort of changes the age to a given value. But inside of the mutator, you can do all sorts of check. So suppose you want to make sure that the age that you are assigning to is larger than 0 because no one. So you have to if ag is larger than 0, then you do this assignment. Otherwise, you just skip this assignment. So you can do lots of checks or any kind of checks that you want to sort of apply, right? And you have to, you can these checks, the purpose of those checks is just to make sure that the input value actually makes sense, right? Of course, you cannot have a negative age, right? And it will just make your class more robust and easy to use. And for int, for this accessor, it's going to return a int, right? It's going to return age. But the thing is that you don't want the user to modify the age. So you want this particular function, you don't want this particular function call to actually make any disturbance to the current state of the private data members. So there's a way for you to actually ensure that, which is by following the function name with the keyword const. So we have looked at the const keyword before, right? If you don't want to change if you want your variable to hold its value without, you don't want the user of your variable to change it. You declare that variable as a const, right? A const variable is just like a parameter. Like if you want a parameter like a pi to hold the value that's like a 3.14 something, then you declare that variable const so that user cannot make any modifications to that parameter. But in that case, the const is actually comes in front of the declaration of the parameter, right? You do a const float or const double pi equals to 3.14, that kind of thing, right? But here you're actually putting a const after the declaration of the function name, right? It actually has different meanings. It actually has different meanings. If you put the const here, it means that this age function is going to return a integer, a constant integer, an integer that doesn't allow you to change. But if you actually put the const here, it's the same keyword, but it has a very different meaning. It means that this function, this int function, is not allowed to make any changes to the data members of this object. So this is going to be a const function, a function that's not allowed to make any changes to the data members of this object. So this is basically a way to tell the compiler this function won't change the data or won't change the state of the object. So let's still build it. And let's still run it, and the behavior of the code should be correct. And of course, this is just for age. You can also do other accessors and mutators for other data members. For example, name, sex, those vitals. Those vitals is you might want to do accessors and mutators for the vitals by using the vector object. One of the important advantages of using a object-oriented programming language is that it promotes code reuse, actually. So it actually makes reusing existing code a lot easier. And there are two basic mechanisms for code reuse. One is called composition, and the other one is called inheritance. Composition is relatively easier to understand. You can define your own class. For example, I have defined my own class that's called person, and then you can have data members. You can have data members that are objects of other classes. For example, I have a string. I have actually two strings in my person class, and I have a vector in my person class. The string and vector are classes that's already defined in the standard template library. So that comes with the C++ language. So I'm actually doing a composition here. So all those private data members of my person object, the name, the sex, and the vitals, can access all those member functions and all those data members of, for example, the vector object, a vector class, and then the string class. So suppose I would like to get the size of vitals vector. I can just inside of my class definition, I can do a for example, I can write a piece of code that returns the size of the vitals. How many elements do I have in the vector by calling the member function size. For example, suppose I want to return an integer int vital size, and it takes no input, and then all it's gonna do is to call the vitals dot size, and then that's it. So here I'm actually calling the size member function of a vector, and then I return the result, and the return the result is like I returning it as a int, and this might not be a good way for doing that because the return type for the size member function of a vector is not exactly int. It's some kind of unsigned int actually. So it's a type of size t actually. So you can actually build it, and now you have a member function called vital size, and it actually calls the size member function of a vector. So you don't really have to write your own size function to return a size for the vector. You can just use the size function that's already written for a vector inside of your class. So this is one of the ways for reusing the code through composition. This is called a composition, and the composition relation can often be expressed using composition. Let me write a comment here. Composition relation has a relation. So if you have two classes and one of the class has an object of the other class, and then this is a composition relation, which means that you might want to define a data member using the other class, inside of this particular class. It is a has a relation. So if something has something else, has a object of something, then it's a good place to use composition, just like defining data members, this kind of thing. And then, but the emphasis here is not really composition. The emphasis here is inheritance. What exactly is the inheritance, right? Inheritance is a relation. So inheritance is another way, a major approach for code reuse. Inheritance expresses a relation. So let's look at one of the scenarios. Suppose here's my class definition. You can collapse the entire definition by clicking on this symbol. So in the IDE, suppose I wanna define a new class, and this class might be something that's kind of a specialized person. For example, I'm gonna define a class. I'm gonna call this class lawyer, and a lawyer is a person first, right? So this is essentially a relation. So in this kind of case, you may want to use the inheritance relation, and then the inheritance syntax looks like this: class lawyer, and then colon, followed by the keyword public, and then the name of the base class. Let's use a person, and then you can define the body of the lawyer here. So this is a relation. So a lawyer is a person. So you can use is a relation. You can express is a relation using a inheritance. You cannot say a lawyer has a person. It's not has a relation, right? But on the other hand, if you, for example, if you have a class that's called a committee, so a committee has a person, right? It's not, a committee is not a person, but a committee has a person. So in this kind of case, you can, for example, define data members. For example, you can define a person as the chair. For example, you can have a private data member that's called a chair. That's called a chair, and then you can it can be a person object. So this is a has a relation, but this is actually a is a relation. So you can sort of see the kind of distinction between composition and inheritance. So they actually express different kinds of relations. Now let's look at the syntax of the inheritance in a little bit more detail. So you have a new class definition, and then followed by colon, and then followed by the keyword public, and then the base class name. So the word public here actually means that you are doing a public inheritance. It's so a public inheritance means what? It means it does not mean that the private data members inside of the person class will become public in the lawyer. The private data members inside of the person class is still going to be private for the lawyer for the lawyer class. It just means that the public members, either public data members or public member functions inside the person, are still going to be public in lawyer. So you can also imagine that there's also a keyword called private, which is going to describe a private inheritance relation, right? If you are having a private inheritance relation, which means that the public members in your base class will also become private in the derived class lawyer, and that kind of a private inheritance is not used very often in practice. So the majority of the dominant majority of the applications are still using the public inheritance, because you would still like to, the reason that you are actually inheriting one of the most important reasons for inheriting a base class is to use its member functions, is to use its public member functions. So you would like to use the public keyword to describe the inheritance here. Now let's look at how we can actually write this lawyer class, right? So one thing that we might want to do is to introduce a new data member, for example. So we're gonna introduce a new private data member that's called license, and it's a string, because a lawyer may have a license, and you want to record that information. So this is a new data member, and it's gonna be a new data member in addition to the private data members that's already inside of person. That contains a name, age, sex, and vitals. So you're actually adding one more data member to the lawyer class in addition to all those data members that's already inside of the person class that's you're deriving from. And then suppose we want to write we want to introduce some public functions or public member functions, for example. So the first thing we're going to do is to write constructors, of course. We need to sort of provide some constructors for this lawyer class, L8WYER. Of course, one of the constructors can be the default constructor, so it takes no input. And if that's the case, if that's the case, we're gonna call the default constructor for the base class, and the body of the function can be just empty. So this is actually lawyer. This is a default constructor for the lawyer, and then colon means what? When we did actually the constructor initialization list, we used the colon here. For example, when we did the default constructor for the person object, we used the colon, and then followed by a list of all the initializations. So here I'm actually calling the default. I'm actually calling the constructor of name, the string object name, and then this is actually initialization of integer, and then another initialization of calling the string constructor actually, and then that's calling the vector constructor with some kind of initialization. So basically, inside of my initialization, I can actually call the constructors of my data members. Here, the same is also true for inheritance. So here it's a default constructor, and in the initialization list, I can actually call the constructor or the default constructor of my base class, that's person, and the compiler is going to recognize that. So I didn't get any compiling error for here. So it actually allows you to actually use the base class constructor. So this is for default constructor. Of course, I can also define a constructor that's gonna accept input parameters. For example, I'm gonna use exactly the same set of input parameters as my constructor for the person, including a name, age, gender, and then the vital information. So I'm gonna copy this thing over, and here I'm gonna call the person constructor. I'm gonna call the person constructor with the same inputs as the input to the lawyer constructor. So it's basically name, NAM, and then age, AG, SC, that's sort of the gender, and then the VI. Again, I don't really need to put any additional information into my initializer. So if I but now because I have a new data member that's called license, it's a string of license. So I can sort of I can add this some new information about the license. So suppose I have another string input that's called LIC, and then I can initialize this license variable using LIC. But how I'm going to do that? I'm still going to do it in the constructor initialization list with a comma and then LIC. I'm going to call LICENSE and then LIC. So I'm going to initialize my license using LIC, That's one of the inputs. That's one of the inputs. So basically here I'm actually calling the constructor for the base class, the person, and then here I'm actually calling the constructor of the string object, which is the data member. So this is actually using the constructor of the base class, and here it's actually using the constructor of a data member, a composite class, a composite object. It's a data member. But here the compiler is going to complain because what I was telling you in a previous video, I was saying that the default parameters here, I'm actually using default parameters, has to be applied to just the trailing parameters. So here I have default parameters, but for the last input parameter, I don't really have a default parameter. So maybe I should just give it an empty string as default parameter. So if the user actually enters a new license number as for the license, then it's going to use that AOIC. If the user does not enter the license for that lawyer, then it's going to just use the default one, which is the empty string. And if we compile it, it will show no mistakes. So that's another constructor that we can actually use to initialize the lawyer object. The important thing to remember is that inside of this constructor for the derived class, you can call the constructor of the base class, and you can also call the constructor of your data members if some of your data members are actually objects. Right? In this case, license is a string object, so you can call strings constructor to initialize your license. And one of the pitfalls that one of the mistakes that people often make is to, inside of this constructor, you directly initialize the data members in the base class. For example, if you try to do that, for example, if you try to do instead of doing AOIC license AOIC, suppose you do name NAM, then it's going to generate an error because the name data member is a private data member in your base class. It's not a private data member in the derived class lawyer. It's a private data member in the base class, and you don't really have in the derived class. You don't really have access to the private data members of your base class. So by doing this kind of initialization, the compiler is going to complain, and it's going to say that you don't really have access to that to the private data member of the base class. So if you want to access those, if you want to initialize those private data members of the base class, you have to go through the constructors of your base class actually. So that's why you need to call the constructor of the base class in the initialization list for the derived class. Now let's try to make the example slightly more interesting by adding some member functions. So suppose I add one more member function. Let's just add one more member function to the person class. We're going to call it work. So a person can work. So if you don't have a job, your job is to look for a job, for example. So I'm going to see out looking for a job, and then ENDL, end of line. So that's my work function, a member function inside of the person object, inside of the person class. So for my lawyer class, I can also define a work function with exactly the same signature. So it's going to return a void, and then work takes no input, and then I'm going to see out. So a lawyer also can work by talking. So I'm going to just write talk here, ENDL, end of line. So what's going to happen? What's going to happen if I call the work function on a lawyer? Is going to call the work function of the person, or is it going to call the work function of the lawyer, this new member function for the derived class. And the ID is actually telling you what's going to happen actually. So you have a triangle here. If you move your cursor here, it's actually shadows person work. It's actually showing shadows person work here. So it means that this work function is going to override the work function that you have defined here. So let's give it a try. So let's see what's going to happen. So I'm going to define a lawyer. Let's just call it AO. And then I'm going to initialize it with some information here. But let me give some kind of some last name, AW, for example. So if I do AO dot work, let's see what function is it going to call actually. So it's going to call talk. It's going to call the work function that's defined for the lawyer. So even though you have a public inheritance from person, so it makes the work function available inside of the lawyer. So this work function for the person is actually available inside of the lawyer class, right? But if you actually write your own work function for the lawyer class, it's going to execute this new work function. So this new work function is going to override the old work function that's sort of inside of your base class. And if you actually don't define this work function, suppose you comment out this particular work function, and then if you still call work, and then it's going to go back to the work function that's defined for the base class looking for a job. So it's going to call this particular function, the work function that's inside of the person object. That's the base class. So which means that this example means that you can change the behavior of a class if you don't like the old behavior of the base class. You can just change it by defining your own function. Right. So we also have another function that's inside of the base class. That's called a print, which is basically a function for printing out the name, the age, the gender, the vitals, this kind of information. So, and that function is defined here. It's declared inside of this class definition, and then the definition of the function is actually goes here. So it's basically printing out some sort of divider, and then name, gender, vitals, that kind of thing, that kind of information. Suppose we would like to write our own print function also. It's still gonna be exactly the same signature as the print function defining the person object. The signature means a signature function means the return type, the name of the function, and then the input list. So the three things is actually identical. The three things are identical in the derived class to the signature. So to the signature that's sort of in the base class. But in the derived class, in the body of the derived class, I'm gonna call the print function of the person of the base class. So how can I do that? Again, I can use the scope operator. The scope operator. I can call the person print the person's version of the print function by prefixing the print function with person. So here I am actually calling the print function of the person, the base class object. And then I'm going to append something. I'm going to see out another maybe another divider, for example. And then I'm going to sort of print out some occupation information. So if I sort of do another cout occupation lawyer, and then followed by license, and then maybe another divider. So that's my new print function. It has exactly the same signature as its base class. And inside of this print function, I'm going to call the base class print function. And then add some additional information. So make it easier to read. All right. Let's build it. But this time maybe I should initialize the AO object with a license. For example, let me just give it some kind of random number. And then let's call the print function. This talk is actually coming from l.work. I'm calling the work function, and then l.print. It's gonna print out. This is actually coming from the call to the base class print, and then this actually comes from the added information, that I added here. So you can still inside the function of your sort of derived class, you can still call the function that's inside of your base class by just prefixing it with the class name and then the scope resolving operator colon, and then you can just call that function. Now let me try to show you another feature that's of inheritance that's called upcasting. Suppose I want to write a function that's going to check the vital signs of a person, and this function doesn't really belong to any of the classes that I have defined so far. It doesn't belong to a lawyer, doesn't belong to a person. So I'm going to write an independent function that's just called void check vitals, and it's going to take a person reference to a person as input, and it's not going to return anything. So the vital is before we actually write the body of the function, we're gonna have some way to need some way to access the private data member that's called the vitals of a person, and the vitals is stored in this vector floats in a person, and it's a private data member. So we need to write an access function for returning the vitals. So what I'm gonna do is that I'm gonna write the access functions following the age. So I'm gonna call it vitals with the capital V, and then it's gonna take no input, but it's gonna return an auto. And then I have to make sure that it's a const function because it cannot change the value of the private data members. It's just returning the private data members. So I'm gonna return the vitals. I'm just gonna return the vitals. So this is a sort of access function that will not change the value of the vitals. So that's the const here, but it's going to return the vitals as a float of vectors, a vector floats actually. So now I have the access function. Now I can write my check vitals function. So I'm going to define a variable that's called heart rate. So in this function, I'm just going to use the heart rate, which is the first element of the vitals. So I'm actually calling the access function of the person P, and then I'm taking out the first element, that's 0. So I'm taking out the zeros. So now I got a variable that's called HR, and the HR is supposed to be some kind of a float. So I'm gonna do some comparisons of the HR. So if HR is larger than or equal to like 60, for example, and so if you want to do conditionals, these two ampersands together means and. So and means that this condition has to be true, and also the condition that's behind it also has to be true. HR is smaller than or equal to 160, for example. And then I'm gonna see out healthy. So the and means if both conditions are true. If both conditions are true, then the entire thing that's inside of this parenthesis is true. So if both conditions are satisfied, I'm gonna print out healthy. And else if So I can do this kind of else if construct to account for situations that's not defined by these two conditions. So which means that the heart rate HR is either smaller than 60 or larger than 160. So else if I'm gonna see out, I'm gonna give the condition. So if uh, if uh, if HR is larger than 160, I'm gonna see out, take a rest. So the heart is beating too fast. I'm gonna ask the person to take a rest. And else if HR is smaller than, for example, 60, and HR is larger than 0, I have to make sure that heart rate is indeed larger than 0, because if the heart rate is smaller than or equal to 0, then it means that it's a dead person. So I'm gonna see a doctor. And else, that's the only situation that's kind of left, which is the heart rate is smaller than or equal to 0. Then I'm gonna see out, you're dead. So that's gonna be the body of my function called check vitals. So now let's go back to the main function. Here I have defined a lawyer. I have defined a lawyer here with some kind of information. Right? No, but what I was telling you that because lawyer is derived from the person class, which means what inheritance is a relation. So a lawyer is a person. The check vitals function actually takes a person. The check vitals function takes a reference to a person as its input. So what I can do is that I can put the lawyer into check vitals as an input and see what's going to happen. Let's see what's going to happen. So what I can do is to call check vitals, and then I'm going to give the L as its input. And let's see what's going to happen. Again, the same mistake. I should have sort of moved this semicolon into inside of the curly brackets, and then let me build again. So now it actually passed. It has passed the compiler. Now let's run it. It's going to tell me healthy. So a function that's defined, a function that's going to use a base class as input can actually take a derived type. Of course, it can also take a person. So suppose I initialize a person P, Bob. I'm just gonna copy this line here. It can also take check vitals. The check vitals can also take P also, and it's not a problem either. So let me just comment out this line. Then let me just run it. So healthy and then healthy again. So suppose I change this thing to 0. I'm changing the heart rate for the person Bob to 0, so the printout is going to be different. So for the lawyer, you are healthy. It's healthy because the heart rate is 75. But for Bob, the heart rate is 0, so it's actually printing out you are dead. So basically, it's actually telling us that the check vitals, even though the definition of the function is actually for a input of person, it can actually take those derived classes. Those classes that's derived from person. So which means that you can actually treat a lawyer just like a person inside of this function. And because lawyer is derived from a person, so the person class is on top, and then the derived class lawyer is on bottom. So in this particular case, you are actually converting a lawyer back to a person. So it's called an upcast because you are actually going from a derived class to the base class. So this is called an upcast. So upcast will happen automatically for this kind of a situation. So for the lawyer class, we now have two constructors. One constructor is sort of the default constructor, takes no input, and the other one takes lots of inputs, but with some of them as default values. And we don't have a copy constructor for lawyer. If we go back to person, we do have a person copy constructor here. That's a person copy constructor. But now let's try to write a copy constructor for the lawyer also. I'm gonna sort of say it's gonna be a lawyer AW, and then the syntax for the copy constructor is you have to give it a const, and then a reference to a lawyer. Let's just suppose the input is L. It's a const lawyer reference L. You have to use this kind of thing as an input for the copy constructor. Now, for the initialization list, what's going to be our initialization list, right? So a const of lawyer as input, a const lawyer reference L. L is a const lawyer reference, but don't forget a lawyer is also a person, right? But okay, so can we actually take advantage of the copy constructor for a person also, right? So the thing that I'm going to do here is I'm going to call the copy constructor of the person, but I'm going to give it the input that's L. So here I'm actually calling the copy constructor of person, and then the input I gave it to the copy constructor of person is a lawyer. So the reason that this syntax actually works is because L is a person. So here I'm actually using upcasting. But by calling the constructor of the base class using the derived class L as its input, I'm essentially upcasting L to the base class person. And then I'm calling the copy constructor of the person. And the copy constructor of the person does what? It does all those initializations. So the only thing that's kind of special is the name. The name is going to change. The name is going to has a sort of suffix underscore copy behind the name. That's the only thing that's kind of different. So here we are going to use the copy constructor of the base class, and then all I have to do is to handle this new private data member license that's not included in the base class data members. So all I have to do is to initialize license by using L.license. Again, this looks like accessing a private data member, but in a copy constructor you're allowed to do that. And then that's the body of the function can be just empty. So now we have a copy constructor for the derived class, which actually uses the copy constructor of the base class, and also the feature of upcasting. I'm upcasting L to its base class. So now let's give it a try, right? Now let's give it a try. So suppose I have I'm going to define L1, and L1 is going to be initialized using L because I have an L here, and then I'm going to do a L1.print, and then let's see what's going to happen. Let's just build it, and then let's just run it. So here it's the information about Bob Law, that's L, and then that's sort of the printout of the two check vitals. Print out the two check vitals, one here and then one here, right? And then here is the initialization of L1, construction of L1, and then the L1 print. It's coming down here. So the only thing that's sort of different from Bob Law is that the name is now Bob Law underscore copy. So this is actually a feature of the person copy constructor, the copy constructor of person class. And everything else is sort of identical, exactly the same, including the license. So that shows you how to actually write a copy constructor for a derived class by using the copy constructor of the base class and also upcasting. For any kind of object-oriented programming language, there are three things that's kind of very important. The first thing is the class, basically. You have to have some way to encapsulate both the data and also the operations that can apply on the data. which is called the behavior. So you have some mechanism to encapsulate both the data and also the behavior. And in C++ language, which is called it is called a class. A class is basically a mechanism for a mechanical mechanism for you to actually encapsulate data together with the behavior. And then the second thing is probably the inheritance. The second most important thing is the inheritance. So you have some mechanism to reuse the codes through inheritance and composition. And in C++ language, inheritance and composition, both of them are kind of implemented, and you can sort of do inheritance like the example that I was showing you, deriving a lawyer class from a base class that's called a person. That's probably the second most important thing. And then there's a third most important thing, which is called polymorphism. Polymorphism is a kind of central to object-oriented programming. It's a design principle. It allows you to decouple the interface from the implementation of the interface. And I'm gonna show you how polymorphism can be implemented in C++ using another example. To illustrate polymorphism, let's just add one more class. We'll derive one more class from the person class, and we're going to call this class soldier. So I'm going to define a new class that's called a soldier, and then it's also going to be derived from public person. And I'm going to introduce a new data member that's also a string, but let's call it a weapon. And then we have some public member functions. For example, we have a constructor, soldier. That's sort of the default constructor. I'm just gonna call the default constructor person, and then a constructor that takes lots of inputs. Vector floats. And in this case, I'm gonna call the, and then there's also another string. Let's call it we equals to, also empty. And then I'm gonna call the constructor of the person. And then I'm gonna initialize the private data member weapon using we, the input of we. And then the body of the function is still empty. So that's my second constructor. So, and then I'm gonna define another function that's called work. And for the soldier, I have the work function is kind of I also have a work function for the lawyer, which is here. Basically just prints out the text talk, and then that's it. So here I'm gonna just also see out. I'm gonna print out a different string that's called fight, and then it's also gonna so basically that's my definition for a soldier class, which is also derived from person. It's also inherited from person class. And let me see if it passes the compiler. It looks like it has passed the compiler, so that's fine, I think. So now let's try to define another function. And again, just like check vitals function here, this function does not belong to any of the class. I'm gonna call it check work, and then I'm gonna give it a person reference, a reference to a person. So a soldier is a person. A lawyer is also a person. What I want to do in this particular function is just to call the work function of each of the person. Doesn't really matter whether it's a soldier or it's a lawyer. All I want to do is to call the work function. So we talked about upcasting. So a soldier is a person, a lawyer is a person. So if I put a soldier into the input, or if I put a lawyer into the input, this check work function should take it. It should be able to actually process it, right? So what I'm going to do inside of the check work, I'm just going to call the work function of P, the input person, and let's see what's going to happen. Let's see what's going to happen. Just build it, and then so it looks like the compiler didn't complain anything. But now let's try to call this check work function inside of the main code. So what I'm going to do is that here I have a lawyer. But now I have to sort of define a I have to define another. Let's call a soldier S, and then I'm gonna give it a different name. Let's just call it Kevin War, and then the rest of the information is like similar. And then I also need to initialize for the lawyer. I need to give it a license number, and then for the soldier I need to give it a weapon, or just say tank. So now I have a soldier object S. I also have a lawyer object that's L, and then I can call check work L, and then check work S. Before I do that, let me just print out some prompt. Check the working for two objects, and let me just exit one. Let me build it, and then let me just run it. So here is actually the printout for check the work information for two objects, but both of them are actually printing looking for a job. So for check works, if I give it an L, it's going to print out looking for a job, and then if I give it an S, it's also going to print out looking for a job. That's not exactly the behavior that I wanted. So what actually happens is that upcasting also still happens. So L is still being upcasted to a person, and S is still being upcasted to a person. So upcasting still works. But the problem is that the work function that's gonna be invoked on this upcasted person object is gonna be the work function of the person. So for the person, that's the definition of the class person. It has a work function, and it's gonna see out the string looking for a job. So it's actually this particular function that's getting called instead of the work function that's in the derived type. So upcasting still works, but it's not gonna call the work function in the derived type. It's gonna call the work function in the base class. So how do I actually still allow upcasting, but the behavior of the work can still be sort of adapted to the particular object that's being sort of passed over. So what I want is a behavior, is a function that can be applied to all the persons, doesn't matter what the occupations are. And then if I call the work function of the input object, it's going to call the work function of that derived type instead of the work function in the base class. So how can I actually implement that? And the mechanism in C++ is actually very simple. All you have to do is to prefix the work function in the base class with the keyword virtual. So if you actually put a virtual in front of the work function of the base class, and then let's just still save it and compile it, and then this time let's run it and check the work for the two objects. One of them is lawyer for the work function for lawyer is going to print out torque, and the work function for the soldier is going to print out fight. So this is actually what we wanted. That's sort of the behavior of our desired behavior. But let's go back and look at what exactly has happened. So in the main function, I have defined two objects, lawyer L and soldier S. Right. So the lawyer class has a work function, and the soldier class has a work function. So what exactly has happened is that the base class, the person class, is actually acting as some kind of interface that allows you to use the common interface to access the different behaviors of the derived class. So what you can do is that, for example, you can actually define an array of persons, and every element in this array of persons can have a different occupation, for example. And you can just loop through every element inside of this person array, using the check work, and every element is going to print out the work. That's sort of the correct work function. It's going to call the correct work function for that particular element inside of that array. So in principle, it's actually a separation of the interface from the implementation of the interface. And the interface is kind of the virtual function that's defined inside of your base class. And then the implementation is actually the concrete class, that has been sort of implementing the specific work functions that's kind of adapted to the specific occupation. For example, here work is sort of printing out the fight, and then here work for the lawyer, the work is actually printing out torque. This kind of thing. So the kind of this kind of behavior is called polymorphism, and it's as important as inheritance. And one of the major objectives for inheritance is not only for code reuse but also for implementing polymorphism. So it's actually important for us to understand how polymorphism actually works. So this demonstration of virtual functions and polymorphism works fine, but there are some minor problems, and the IDE correctly identified those minor problems as warnings actually. So if you actually go to the problems tab, it's showing you warnings, 3 items. So class lawyer has virtual method work but non-virtual destructor. Class person has virtual method work but non-virtual destructor. Soldier also. So it's actually these warnings won't break the code, but it's actually telling you there are potentials. These are potential pitfalls which may introduce problems down the road if you actually make more complicated applications of those classes, for example. And what's actually the meaning of has virtual method but non-virtual destructors, right? So here I have a destructor for the person, which is defined here. It's a public member. It's a public member function. It's a wiggle person. That's the destructor of the person. The problem with the meaning of this warning message is that because you have a virtual function that's defined for work inside of the person, so the compiler is actually expecting you to use person as some kind of interface. So it's going to be a base class. It's going to be a base class for some other classes. And in reality, we're actually using the base class person. We're using person as the base class for lawyer and soldier. So what's going to happen during the destruction process? Suppose the lawyer or the soldier is going out of scope and they have to be destructed. So one possible scenario is that you are using a pointer or using a reference to a person to manipulate a lawyer. And that's exactly what's happening inside of this function that's called check work. You're actually using a reference to a person to manipulate a a a a soldier and a lawyer, because you are actually inside of this check work. You're actually calling the virtual function work. So it's gonna implement the polymorphism. So suppose this reference is changed to a pointer, and you inside of this check work you are destroying that pointer. What's gonna happen? You are deleting that pointer or erasing that memory space of that particular object P. What's gonna happen? Right? What's gonna happen? It's gonna call the destructor of the base class. It's not gonna call the destructor of the derived class. The reason is that the destructor of the base class is not virtual. So because it's not virtual function, so it's gonna call the base class destructor. And this base class destructor will not actually handle the cleanup of those additional data members that's already defined in the derived class. For example, for soldier you have another private member that's called a weapon, and then for the soldier you have for the lawyer you have another private member that's called a license. So what's actually the warning message? The warning message is actually reminding you that if you are actually trying to destroy the memory for a lawyer or a soldier by using a reference or using a pointer to a person, to the base class, then you may have problems. You may have memory leaks. You won't be able to sort of clean up these private data members that's sort of specific to the derived class, because you are calling a non-virtual destructor. So the fix is also quite easy. If you want to remove those warning messages, the fix is also quite easy. All you have to do is to make the destructor of the person, destructor of the base class also virtual. Just add the virtual keyword in front of the destructor, and then as soon as you actually have added the virtual keyword, the warning messages in the problem tab has disappeared, and the program will function exactly the same. And if you run it, it's gonna give you the correct behavior. So if you have a virtual function, if you are using virtual functions, it's better to actually make the destructor of the base class also virtual to eliminate the possibility that you might call destructors. You might call the destructors of you might have to call the destructors of the derived class from the destructors of the base class to handle the memory cleanup. Once you have made the virtual function of the base class virtual, so when the lawyer or the soldier object has to be destroyed, and for example inside of this check work, this kind of function, it's gonna call the corresponding destructor of the derived class, either the destructor of the soldier or the destructor of the lawyer. So the destructor of the soldier and the lawyer is going to clean up its own private data member, and then it's going to call the destructor of the base class. So the destructor of the base class is going to handle the cleanup of all the other data members that's inside of the base class, and that will give you the correct behavior. So always give you the correct behavior. For this particular example, it doesn't really matter if you make the base class virtual or not, because the additional private data members for the lawyer and the soldier is a string. A string is an object that's going to handle its own cleanup, so you don't really have to worry about having memory leaks or that kind of thing. But if you are actually having private data members that's a pointer, then you have to sort of worry about how to actually write the destructor in a correct way. You have to, and you will have to sort of make the destructor of the base class virtual, because in that kind of case you will have to call the destructor of the derived class, to clean up those private data members for the derived class first before you actually sort of call the destructor of the base class. And the ordering of the destruction is actually quite important because the data members of your derived class could have dependence on the data members of your base class. So if you actually call the destructor of the base class first, you're gonna sort of destroy the necessary information that's sort of needed in order to actually clean up the memory or the kind of resources that's sort of defined in the derived class. There's no way to actually get a handle of those resources in the derived class to actually destroy them. So that's going to give you sort of memory leaks or other kind of error messages. So it's important to remember that it's better to actually use the virtual destructor also.